All right, I'm only going to explain probably just the odd examples, and then the other examples will be completed on mute, so you can get some help, but also have a little bit more independence, and you have to be a little bit more self-directed and figure out what exactly is going on. You had a lesson on this in school already, or you watched a lesson somewhere, or got help from someone. So hopefully this is going to be enough to supplement helping you check your work. Or if you are just looking for more practice, hopefully this can give you practice. So I'll show 2 examples on the screen, give you enough time to either just hit pause and write them down, or whatever you might need to do, and then I'm going to do them. So let's start with number 1. If we're doing long division, I have x to the second. I have every power in place. So 2, 1, none, divided by a linear binomial, 1, none. If I were missing anyone, I need a placeholder. This is written horizontally. I'm going to set it up as long division. If I set it up as long division, x squared minus 3x minus 40 is the dividend. That is going to go inside. The dividend and the numerator are the same. The divisor and the denominator are the same. X plus 5. Sorry, my dog is making noise right now. Alice, shh. So we're going to go ahead and divide this. So the way you begin is you take the first, term. So my dog wants to participate. So you're going to take the first term right over here, and you're going to divide it by this first term right out here. So the leading term is x squared, and we're going to divide that by x to the first power. Now the way, that's sort of the best way to divide, what I believe is, don't ask yourself x times what is x squared. No, go over here, x squared over x. The division symbol is really a fill in the blank for us anyway, right? So inside is underneath the castle roof. That's our upper class, goes up top. Outside, lives outside, the peasants. Lower class goes on bottom. Now we reduce this, x squared over x, and we get x. Okay, where do we write that? That's the quotient. We write that up here. When all is said and done, you should have all your quadratic terms in a column, linear terms in a column, and constant terms in a column. If you have that, you're looking great. You take this term, you multiply it by your divisor. So I'm going to do x times x plus 5. That gives me x squared plus 5x. Now I say this phrase every time. Parentheses, minus sign, underline, cancel. I never distribute inside and write it down. I do it in my head, so I know what the original problem was if I go back to check something. So I have negative 3x minus 5x, which gives me negative 8x. I drop down the next term, minus 40. From here, I have a new leading term. It's still underneath the roof, right? So it's still upper class. So I'm going to have negative 8x over x, and that will leave me with negative 8. That gets written up here. If I just got 8, it would be plus 8. Now the negative 8 multiplies by that, I get negative 8x minus 40. Parentheses, minus sign, underline, cancel. Negative 40 minus negative 40 is plus, gives me 0. That 0 means the remainder is 0. If the remainder is 0, that means that this is a factor of this. So x plus 5 is a factor of x squared minus 3x minus 40, and so is x minus 8. That is also a factor of x squared minus 3x minus 40. So if we want to kind of finish this up with sort of a complete thought, you can write something like x squared minus 3x minus 40 divided by x plus 5 is equal to the quotient of x minus 8, the, I'm a little cut off, remainder is 0, therefore x plus 5, and don't use a plus sign, x minus 8 are factors of x squared minus 3x minus 40. Now actually, since they're both linear factors and prime, they create the factored form of this. It's easy to see because we're dealing with the quadratic, which you guys are familiar with. You know, you dealt with quadratics for quite some time. All right, but as these polynomials get more intense, we'll have to deal with more factoring beyond the division. If you get a remainder that isn't 0, you would take that remainder and you would do plus the remainder, or if it's a negative, you could just write minus that remainder over whatever you were dividing by, in this case, x plus 5. We really don't need to do it in this case because, well, the remainder is 0. So it's sort of silly to write it that way. And that's all there is to number 1. So I'm about to do number 2, but I will not be giving an explanation for this one. I'm back to talk us through this example. Divide x to the third by x, and that will give us x squared. Again, we have one more term, 3, 2, 1, none for my powers. Everyone's accounted for. Everything should be in columns when all is said and done. So x squared, my quotient for that part, goes up there. We multiply this by this entire expression. So I'll get x to the third minus x squared. Parentheses, minus sign, underline, cancel. That subtracts, it's gone. 3x squared minus negative is plus, another x squared, 4x squared. Now I'm going to set up this next part, 4x squared divided by x, which will give me 4x. Okay, so we divided x cubed, and we got the x squared quotient, which is that piece right over there. And we just did 4x squared. We divided that by x, and we get 4x, and that's going to go up here. This x right there is the x in the denominator. Okay, 4x times x minus 1 is 4x squared minus 4x, parentheses, minus sign, underline, cancel. Negative x minus negative is plus 4x will give us 3x. Make sure you take your time on those and don't make any careless mistakes. We bring down now the plus 2. Again, we will have 3x divided by x. That will give me 3. Once you get a constant for your quotient, you're probably done. You want to make sure you go all the way down to a constant term. Sometimes they're sneaky and they make the term that you need a placeholder for the constant term, and people think they're done, but you do need a plus 0 at the end right there. So here, there's the numerator. There's the answer. That came from there, and that will go there. So plus 3. Now we're going to multiply that. So 3 times x minus 1 is 3x minus 3, parentheses, minus sign, underline, and cancel. 2 minus negative 3 is really 2 plus 3, and that will give us 5. So where did this all come from? Sorry, my dog's participating again. That multiplied by that, and it gave us, where is it? Oops, that line down there. Okay, and this guy over here is our remainder. Okay, so that 5 is the remainder. We can label that. We should see everything in some nice columns for us. And from there, because we have a remainder in this example, we're going to go ahead and write plus, and we're going to add the remainder to the end. Now the reason it's a remainder is because it didn't divide. So it has to be over the thing we're trying to divide by, x minus 1. So that remainder of 5 impacts this part of our equation of our quotient right over there. Okay. Now there are a few tricks and ways to check your work. So I'm going to point one out to you guys now. If you take the inside, which was x to the third. So x to the third, you'll see what I'm doing. This is a way to check your work. And we'll explain what this is at a later time. X to the third plus 3, x to the second. I'm setting it up with parentheses because we're going to plop a number inside there. So I'm taking my dividend, my numerator, minus x plus 2. Now, we're going to plug a number in for x and see what answer we get. Now you take your divisor, x minus 1, and we set that equal to 0. We solve, you add 1 to both sides, so like the zero product property, right? And we get x equals 1. I'm going to take that 1 right there. And what I'm going to do with this 1 is I'm going to fill it in everywhere I have an x and evaluate. So I'll get 1 to the third plus 3, 1 squared, plus, oops, not plus, minus 1 plus 2. 1 to the third is 1 plus exponents first. That's 1. 1 times 3 is 3. Minus 1 plus 2. 1 minus 1 is going to cancel out, but if you like to go in order, 1 plus 3 is 4. Minus 1 plus 2. 4 take away 1 is 3. And 3 plus 2 is 5. Guess what number you should get if you're correct? Yep, you should get the remainder. So it looks like we're pretty good. We're in really good shape right there, okay? So last of all, sorry, just zooming in a bit, we could say the quotient or the answer is x squared plus 4x plus 3 and 5 over x minus 1. That's our quotient or our answer, our solution to this division problem. I'm going to show you other ways to check your answer, but it's important to realize that this right here is sort of like the mixed number, okay? This is like the big number part of it. This is your numerator and denominator of the little fraction next to it, whereas having something written as that over that would be like the improper fraction. And I'll use that check not on number 4. I'm going to do this one without an explanation, but I will do that check probably on number 5, okay? For this example, I'm not going to talk us through it until I get to the end and show you a different way to check your work and to show you a different way to establish or understand the relationship between the dividend, divisor, and quotient and potential remainder. Okay, so this one worked out to have a remainder of 0. I was kind of hoping it would have a non-zero remainder. That just means that these are factors, and if you multiply them, we will get the dividend. So I guess I'll show you this. One way to check it is if I multiply 3x plus 1 by 3x squared minus 7x plus 2, I should get that. Some people are messing up multiplying these. Some of you are very overconfident and you made up your own method, which no one ever showed you ever. I promise. The only person ever showed you that was probably yourself. So please tune in, pay attention, focus, okay? So I'm going to take this, color coordinate a bit. I'm going to take this 3x and I'm going to multiply it by each of the terms in here. So 3x times 3x squared is 9x to the third. 3x times negative 7x is negative 21x squared. And then 3x times 2 is 6x. Now, here's where you guys will start making up your own math. So please, 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 please focus. You do not close parentheses around this. You carry on. Plus 1. Now we multiply 1 by all of these things. 1 times 3x squared is plus 3x squared. I will put it underneath this because they're like terms. 1 times negative 7x is negative 7x. And 1 times positive 2 is plus 2. Now from here, combine like terms, and we have our solution to this product, or our product to this multiplication problem. So we'll get 9x to the third minus 18x squared minus x plus 2. And that is, in fact, what we had there. Okay, so winner, winner, chicken dinner. We checked, we got it right, we're great. What's our answer to this problem? The solution to this problem is that right there, okay? That is the quotient. Okay, next example. Okay, so now we have one that has a remainder. So I'm going to show you how to check this out. So this, like I mentioned earlier, is sort of the mixed number of the group. And if we wrote it vertically, 9x squared minus 21x minus 20 over x minus 1, this is sort of the improper fraction of the group. They're equivalent. An improper fraction and 9x minus 12, I'm just going to write it and negative 32 over x minus 1, this is the mixed number, okay? So improper fraction and mixed number. Now we did learn a way when we were kids how to change a mixed number into an improper fraction. You would multiply this part by this part, add it to this part, and put it over this. Some of you just learned it, followed, did it, whatever they asked you to do. But if you think about it, we're really adding these two pieces, and we're going to need a common denominator to add this and this. So if I have to add 9x minus 12, which is really over a 1, with, or I'm going to rewrite it again as the minus 32, this is still a lesson right now, how to add rational expressions. X minus 1, or subtract 32 over x minus 1, or say add it to negative 32 over x minus 1. Then I need to take this, which has a 1 on bottom, and I'm going to multiply it on top and bottom by the same thing. I need to multiply this on top and bottom by what exactly? X minus 1. Now we have a common denominator. How do you multiply a binomial by another binomial? Well, many of you might say you FOIL, or we could just say use distributive property. So if I distribute all this, I get 9x squared minus 12x minus 9x plus 12. Then this all has a common denominator, so this can all go together. So minus 32 all over x minus 1. Combine some like terms up here, and what do we get? We get a 9x squared. Minus 12 and minus 9 is negative 21. Plus 12 and minus 32 is minus 20. Sorry, I'm squeezing. Over, well, still over x minus 1. And if you look, what do we have here? Here was my original problem. Right? It's either there, or here, or here. Okay? It's in the improper fraction. We also have the x minus 1, x minus 1, x minus 1, and x minus 1. But we also had our mixed number, which is there and there. And we have our remainder. Still over here. Put a little highlight on the plus. And last but not least, the x minus 1 we were dividing by is still right over there. And it went over here. And it's over there. So you need to take some time to look at what we just did, give it some thought, go right ahead. But then this part over here is just the x minus 1 being multiplied by the 9x minus 12. So let's get a little creative. All right. And that's a great way to check your work. Okay. Definitely awesome. And it helps you practice how to add fractions which have polynomial expressions in their numerators or denominators. Nice. Okay, for these 4 problems, we have to determine whether each binomial is a factor of this polynomial here, x cubed plus 4x squared plus x minus 6. So once you get one factor, you can get the other factors very easily. For example, if you have a number 30, and you are looking for factors of 30, a prime factorization, as soon as you get one number to divide into 30, you're like, well, 2 goes in, 2 times 15. Well, 15 can now be broken down. So it's 2 times 3 times 5. So it's easy to break things down once you get one number to work. And the same is true of these expressions. So as soon as I get one of them to work, I'll figure out the other 2. I know I'm going to have 3 factors if at most, because this is x to the third. So once I get 1 to work, I can figure out the other 2 pretty easily. So if I were to try x plus 1, now you have a couple other options. So I'm going to do everything here the cheap way. I'm not going to do long division. I was showing you a trick. where if you took the thing you were dividing by and set it equal to 0, solve for x, the number you get when you plug this in, do you remember what that number was? If I did -1 cubed plus 4 times -1 squared plus -1 minus 6, do you remember what that number is supposed to tell us? You could rewind, you could check back. What was that number? Not going to tell you yet. You can think about it. This number that you get would be the remainder. If I'd have a remainder of -4, is x plus 1 going to be a factor of that? No way. Your remainder has to be what number in order for that binomial to be a factor of this? Do you remember? Your remainder has to be 0. Okay? So that one's out. That was our work for number 9. That was just another way to do it. And this is actually called the remainder theorem. And we'll learn that more formally in class. But that was your little sneak peek at it. Okay, so let's try number 10 in our cheap way over here. I take my binomial that I'm going to try to divide by, set it equal to 0, solve for x, the number I get, and again, this only works when it's a 1x to the first power, okay? So don't try to use it all the time. This is what I'm going to be using to fill in. So I'll have -2 to the third plus 4 -2 to the second plus -2 minus 6. Next, -2 to the third, -8. -2 squared is 4. -2 minus 6, -8 plus 16. -2 minus 6, well, should have written minus 8, sorry. -8 plus 16 is 8. -2, -6 is -8, and I get 0. Remainder is 0. So, what does that tell me? That tells me x plus 2 is a factor of x to the third, sorry, plus 4x squared plus x minus 6. Okay, now there's a downside and an upside to everything. I know that this is a factor. Now let's look back here. If I know 2 is a factor of 30, how do I get those other factors? Well, you have to divide. Okay, so while you could save time by not dividing when it's not a factor, I could either keep doing the cheap way on both of those, or I can do this other method that I'm going to show you after I divide. So I'm actually going to divide that in. X plus 2. I'm going to divide that into my original divisor over here, x cubed plus 4x squared plus x minus 6. I'm going to show a little bit less work this time. You guys should have the hang of it a bit. If you get sloppy and things aren't lined up anymore, it really does hinder your progress. So I would definitely be careful. Okay, here is what I need. So it's like, oh, I know 2 is a factor, 15 is the other part. This is the 15. So I know I have an x plus 2, and then I also have this quadratic x squared plus 2x minus 3. If you think about it, we had a cubic, which is apparently equal to a linear times a quadratic. You would add your powers. Makes sense. And I'm just going to drop this down another step. This I can factor. Whether you have to, whether you have to do it the long way, you have to show all your work and do AC method and grouping, or if you're a little bit better and faster at factoring, hopefully by now, this will be that right there. That's this factored. So these are my 3 factors. Okay, this line is the prime factorization. I see all of my factors right there. So if I look back at the question, what are my factors? X plus 2, x plus 1, and x plus 3. So x plus 2 is 1. Where's the question? Over here? Yes. We know x plus 2 is a factor. And we also figured that out right here, right? When we did our little sneaky remainder theorem trick, okay? We also, down here, sorry, I have, say, the x plus 3. And it's right there. So, yep. Now the other one here is an x minus 3, and the other one was x plus 1, and my other factor was x minus 1. So I have the minus sign on one, I have the 1 on another one. So those are my factors. So this is nope. Ooh, that pen's not good anymore. Nope. Over here as well. All right, so these 3 on the bottom are the only factors we have, and hopefully you are crushing it at long division. Good luck.